Alright, so for this problem we have a problem concerning two fuel pumps that are used. One is used in action, one is in reserve. If the primary pump malfunctions, then the second is automatically brought online. So each pump is exponentially distributed with mean 100 hours. What's the chance that this thing does not remain functioning for the full 50 hours? In other words, that they both die out in less than 50 hours. So let's find the probability of this. So first, to do this, we note that x1, the lifetime of the first pump, write that out, lifetime first pump, that is exponentially distributed, and the parameter is 1 over 100 because the mean is 100 hours, and x2 is the lifetime of the second pump, and that's also exponentially distributed with parameter 100 hours. I don't believe the problem says so, but it's perfectly reasonable to assume that these are independent. So if they are independent, if whatever happens to one fuel pump is independent of the other, this problem concerns the sum x1 plus x2, the total of these two. And one of our properties is that if I have two exponential distributions with the same parameter, then the sum has a gamma distribution with parameter 2, 100. If I had three of them, then it would be gamma distributed with parameter 3, 100. Okay, so the question is, what's the probability that it does not remain functioning for the full 50 hours? What's the probability that it dies in less than 50 hours? So that's the integral from 0 to 50 of the PDF for the gamma distribution. So that's going to be 1 over gamma of 2 times 1 over 100 squared, x to the 2 minus 1, times e to the minus x times 100th dx. Remembering that, let me just write it over here in the notes, that 1 over gamma of r, lambda to the r, x to the r minus 1, e to the minus lambda x. That is the PDF for a gamma distribution with parameters lambda and r. Okay, now gamma of 2 is equal to 2 minus 1 factorial, so that's equal to just simply 1. And so I can rewrite this as integral from 0 to 50 of x over 100 times 1 over 100 e to the minus x over 100 dx. Now the reason I write it like that is so that I can use integration by parts. So equals integral from 0 to 50, x over 100 times, this part here in parentheses is the derivative of negative x over 100. And so applying integration by parts, we get negative x over 100 times e to the minus x over 100. Then minus a minus becomes plus, integral from 0 to 50. The derivative of x over 100 is 1 over 100 times e to the negative x over 100 dx. Okay, then I integrate this, and so I end up with negative x over 100. I'm sorry, this should have been evaluated from 50 to 0. E to the minus x over 100 minus e to the minus x over 100, where both of these get evaluated between 50 and 0. Okay, so we plug in. Plugging in 50, we get negative 50 over 100, e to the minus 50 over 100, minus e to the minus 50 over 100. Plugging in 0, we get 0 minus 1. And so our answer will be 1 minus 3/2 times e to the negative 1/2. And so whatever that is, that's the probability that the thing dies in less than 50 hours.